This is a home automation quick byte. Raspberry Pi series. We proudly present Servo motor. The digital recipe ingredients are Raspberry Pi with power adapter, connecting wire, external 5-volt power supply, and the servo motor. See description below for links to these products if you don't have them. This is the original circuit that I went with to test the servo with the Raspberry Pi. Most servos require too much power and really should be connected to an external 5-volt power supply rather than the Raspberry Pi. So that's what I went with secondarily, and we'll show it in our actual video of the Raspberry Pi and servo working. In that case, you would just take the 5 volts and the ground and you connect that directly to the external 5-volt power supply. And then you take the ground from the external power supply and the ground from the Raspberry Pi and you connect them together. So how do we program the servo using Node-RED and the Raspberry Pi? First things first, find out where your Raspberry Pi address is, put :1880 in your address bar above, and you should have a screen that looks something like this. It'll probably just have one flow. It'll say flow number 1. It'll be a blank screen, and off you go. The first thing you want to do is power up the servo. And although our schematic shows the server connected to the Pi for power, because it's quite small, it does work. The recommended thing to do is to connect it to an independent 5-volt power supply. And then you connect the grounds together from the independent power supply and the Pi. And this way, they have the grounds are together, the power is separated, and it should work nicely. The servo itself usually works around 50 hertz. It could be different. It's always good to check your spec sheet and see what's needed, but 50 hertz should work for most things. Pulse width modulation. Sounds scary. It's not. You don't really need to know other than to select it in the PWM key. See, if you go here to set it up, I pick pin 13 and then you scroll down. And you want the output to be PWM. It's usually digital, but you want to make sure it's on PWM. You put the 50 hertz, and that's it. You hit done, and that's all you really need to know about it. But if you want to know a little more, we could read this little sentence I wrote. The width of the pulse that is sent to the server determines its position. If the pulse is skinny, then the servo swings to one end. And if it is quite fat, then it swings to the other direction. The width of the pulse is dependent on the number we send it. In this case, from 1 to 12. And for exact widths for your servo, look up at the spec sheet for your servo. Okay. My servo works with values from 1 to 12. And it moves the servo between 0 and 180 degrees. Your numbers may be a little different. It may be 2 to 13. It may be bigger numbers. Check your spec sheet to find out what it needs. The servos usually come with different arms that you can attach to them for different use cases. Like you could have a straight arm out of each side. You could have an arm that comes out only on one side. It could have a T. And you would use them for different things. All right, let's get to the programming. On the left side, we have a bunch of inject nodes here. And they are what's going to start this up. On this side, we have the PWM. We have a debug if we need it. And we have some function nodes and a whole bunch of things here on the bottom. At first, we're going to look at the top. It's divided into two parts. The top is simple way to do it. And the bottom is using some function nodes to do something more interesting and a little more complicated. So if you're interested in the JavaScript, we're going to go through that part too. So let's start at the top. So we're going to send values to this PWM GPIO 13, which is where the wire is connected to the server, and we're going to send it a 1. And you can look at the status bar here. See, we sent it a 1, and you may be able to hear the servo, which is just right next to me, as we do this. So 4.5 degrees is going to be 4.5, which is 45 degrees. And then the middle, between 0 and 180 degrees, is a 6. So it should be sitting at 90 degrees at the moment. If we want to move over to 135 or 45 degrees off the right side, we send it a 7.5 and it moves over. And then all the way over 180 degrees, we send it a 12. So we're going to sweep all the way to the other side. That's 1. I mean, you probably could hear it behind me. It's sweeping back and forth. So simple. Now we could do something a little more fun. In here, we're going to do what I call a sweep function, whereby, well, let's try it out first. I'm going to hit the sweep, and you see a 1, a 2, 3. So every 3 seconds, it outputs the next number up. 4, a 5, a 6, 7, 8, 9, 10, 11, and 12. And there you go. And that's a sweep. How do we do it? Well, first of all, we have the inject node into the function node to activate the function node. Let's look in here. So here's some JavaScript for those that are interested in JavaScript. In JavaScript, you can go 2 ways with it. You can really try to learn it, or you can somewhat learn it and do a lot of copying and pasting. And then after a while, you just have a better understanding and you really do learn it. So what we're doing here is we're initializing I equals 0. And then we're setting up a for loop. I equals 0 to I equals or less than 12. And then we're going to increment by 1. So the loop, every time it goes around, it goes 1, 2, 3, 4, and so on. Then we have the set timeout function, which is all the rest of it here. It's a function that is used to do the 3-second timeout in. So you'll have all this part here, which is standard. You just copy and paste it, not even to think about it. And then this is what's doing the incrementing. So I equals I plus 1. So if I starts off at 0, this starts off at 1, and then the message payload equals 1. And then we do node.send message versus return message, because it will only work using node.send in this kind of for loop. And then you just loop back around. The set timeout is a standard function, and it uses the number here. This is in milliseconds. So if you want 3 seconds, you got to do 3,000. If you want to do 2 seconds, you do 2,000. 1 second's 1,000. And then times I. Okay, so if you're interested up to this point, it's good enough. If you're interested in why it's times I, when you do set timeout, it creates a bunch of timeouts. It says, ooh, I'm going to need 12 of them, because it already knows what's going on here. And they're all set up in a row. So it doesn't give you a timeout and then another timeout. It gives you all the timeouts, and then the last timeout gets a 3-second delay, and then it just does it once. So you have to do the times I, because then it'll do 3,000, because it's 3,000 times 1. It'll go back around, it'll be 6,000, which would be 6 seconds. And they'll give another timeout. And 3,000 times 3, 9, which is 9 seconds. and it goes back around, so forth and so on. So it just keeps incrementing these timeouts that are just sitting in a stack, and it sends them out appropriately. And that's that. It's pretty simple. The random, basically, it's a whole number from 1 to 12. That's it. Very simple to set up, very simple node. No problem, it gives you a random number. Now, because it's random, sometimes you could get a 10, a 10, a 10, because it's random. It could still be the same number. And then the last one is the Pi keyboard. This comes in the Raspberry Pi section where you get the GIPIO. As you can see, they're the same color. Problem is when I press 1, it actually outputs a 2. And I press 2, it outputs a 3. For some reason, it just, now I can leave it that way and just remember it. I thought, you know what, a little more JavaScript wouldn't hurt it. So this JavaScript, all it does is remove 1. So if it receives a 2, it outputs a 1. It receives a 3, outputs a 2. So we take the message payload that's coming in, the 2, and it's equal to 2 minus 1. So the new message payload will be equal to 1, and then it returns the whole message object. And you're done. And that is everything that's in this flow, excuse me. And we are going to put all this information on the website of toolbeltworkshop.com, just like we have with the other ones. So be sure to check out toolbeltworkshop.com and electricaltime.com. We would really appreciate it. Thank you, and keep coding. Okay, let's go into the lab and look at our servo on the breadboard. We have the Raspberry Pi on the left with the blinking yellow LED that shows us that node red is running. If you want to learn more about that, check out episode 1. We'll have links in the description below. The servo is connected to an external power supply on the bottom, with the green wire as positive and the orange wire as negative. The orange wire is tied into the top rail above at the top of the screen, with the other ground coming from the Raspberry Pi. And now let's go to our different scenarios that we had set up, that we just spoke about. Let's do left, 45, middle, 135, and right. Let's do a sweep. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let's do a random number. Here we have 10, 7, 6, 3, 2, 11. And let's do our Pi keyboard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And that's all the combinations that we had set up.